Section 2.2, Multiply and Divide Monomials. In this section, we will simplify expressions that contain exponents, multiply monomials, and divide monomials. Repeated multiplication of the same factor can be written in two ways. We could, for instance, in this example, we have 4 times 4 times 4 times 4 times 4. We could write that as 4 to the 5th power since we're multiplying 5 4's together. The 5 is the exponent, the 4 is the base. So this expression, 4 to the 5th power, is in exponential form. The exponent 5 indicates how many times the base 4 occurs as a factor in the multiplication. Let's evaluate negative 4 to the 2nd power and the opposite of 4 squared. Now notice these look very similar. Negative 4, the negative 4 squared, notice the negative 4 is inside parentheses. If it's a negative number, it needs to be inside parentheses. This is not a negative number here. It's the opposite of 4 squared. The negative 4 is squared only when the negative sign is inside the parentheses. In negative 4 squared, we are squaring negative 4. So if we expand this, negative 4 squared would equal negative 4 times negative 4, which equals positive 16. In this example here, we are finding the opposite of 4 squared. Or you could think of it as being a negative 1 times 4 times 4, which would equal negative 16. Let's evaluate these. So in A we have negative 6 squared. This will equal negative 6 times negative 6, which is equal to positive 36. In the next example, this is not negative 6 squared. We need to think of it as being the opposite of 6 squared, or we can think of it as being a negative 1 times 6 times 6, which will equal negative 36. In the next example, we have negative 6 cubed, or negative 6 to the 3rd power. This would be negative 6 times negative 6 times negative 6. We're multiplying 3 negatives together, and that's an odd number of negatives, so that would equal negative 216. In the example below here, this is not a negative 6 to the 3rd. This is the opposite of 6 cubed, so we need to think of it as being a negative 1 times 6 times 6 times 6. Notice this will also produce negative 216. However, C and D are negative for different reasons. In C it's negative because we have 3 negatives being multiplied together. In D it's negative because we're multiplying it the 3 6's times a negative 1. Alright, let's evaluate the following. We have negative 3/4 raised to the 2nd power. Now if you want to, you can just think of this as being negative 3/4 times negative 3/4. A negative times a negative is positive. We can just multiply straight across. 3 times 3 is 9, and 4 times 4 is 16. In the example below that, we have negative 3/4 times negative 3/4 times negative 3/4. 3 times 3 is 9, and 9 times 3 is 27. 4 times 4 is 16, and 16 times 4 is 64. And notice we have 3 negatives we're multiplying together. That's an odd number of negatives, so our answer should be negative. Now, the next example, G, is a little bit different because what we have is the opposite of negative 6 squared. So you can think of there as being a negative 1 in front of the parenthesis as well. So this would be a negative 1 times negative 6 times negative 6. Well, 6 times 6 is 36, and 36 times 1 is still 36, but we have 3 negatives, so our answer will be negative. In H, once again, this will be read as the opposite of negative 6 cubed. There's also a negative 1 in front of the parentheses. So if we expand this, this would be like negative 1 times negative 6 times negative 6 times negative 6. 6 times 6 is 36, and 36 times 6 is 216. And notice we have 4 negatives. That's an even number of negatives, so our answer will be positive. Note that in the exponential expression x to the 5th power, x is the base and 5 is the exponent. So the exponent indicates the number of times that the base needs to multiply by itself. So notice below here we have x to the 3rd power times x to the 2nd power. Well, if we expand x to the 3rd power, we could think of that as being x times x times x. And times x to the 2nd power, which expanded, would be x times x. So what we really have here is the base x being multiplied together 5 times. So x times x times x times x times x, we could write as x to the 5th power. So notice we started with x to the 3rd power times x to the 2nd power, and that's equal to x to the 5th power. So this takes us to our first rule for exponents. If we multiply 2 or more monomials with the same bases, we're going to add the exponents of the like bases. X to the 3rd times x squared is equal to x to the 5th. Notice the examples on this slide. We have x to the 4th times x to the 7th. We have the same base x. So to multiply these, we add our exponents. 4 plus 7 is 11. So x to the 4th times x to the 7th is x to the 11th. We have y times y to the 5th. Remember, although we don't put the exponent 1 on the y, there is an implied 1 there. So that would be y to the 1 plus 5, which equals y to the 6th power. In example 3, we have a squared times a to the 6th times a to the 1st power. So if we add those exponents together, 2 plus 6 plus 1, we get a to the 9th power. X to the 4th times x to the 3rd power, that would be x to the 4 plus 3, which will equal x to the 7th. In example J, we have x squared y to the 4th times x y to the 7th. Now, once again, there's an implied exponent of 1 on the x. So we look at our like bases x. So x squared times x to the 1st. That's going to be x to the 2 plus 1. We have y to the 4th times y to the 7th. That's y to the 4 plus 7. So we end up with x to the 3rd, y to the 11th. On k we have 6x to the fourth y times negative 4xy to the sixth. So the coefficients 6 and negative 4, we're just going to multiply those together. So 6 times negative 4 equals negative 24. And now we have an x to the fourth times x to the first, so that's going to be x to the 4 plus 1. That will give us x to the fifth power. And then we have y to the first times y to the sixth, so that's y to the 1 plus 6. So that will give us y to the seventh. So our answer is negative 24, x to the fifth, y to the seventh. The same with L. We have 7x to the sixth, y to the fourth, times negative 5x squared, y to the ninth. We'll multiply 7 times negative 5, which is negative 35. We have x to the sixth times x squared. That's x to the sixth plus 2, which is x to the eighth. We have y to the fourth times y to the ninth, which is y to the 4 plus 9, which is equal to y to the 13th. So our product is negative 35, x to the 8th, y to the 13th. Now notice here, in examples m and n, we're multiplying 3 monomials together. And notice there's a 1 here, okay? So look at your coefficients. We're going to multiply 2 times negative 3 times 1. That equals negative 6. You may want to put the 1 on the a so that you don't forget about it. We're multiplying a squared times a to the first times a to the fourth. And we're going to add our exponents because we're multiplying. So we're going to have a to the 2 plus 1 plus 4, which is equal to a to the seventh. And then it looks like we have b squared times b squared times b squared. That's b to the 2 plus 2 plus 2. And so that's equal to b to the sixth. Negative 6, a to the seventh, b to the sixth. And we'll simplify number or letter n the same way. So first we're multiplying 7 times 3 times 5. Which is equal to 105, and it's positive. And then we're looking at our a's. We have a times a squared times a cubed, so that's a to the 1 plus 2 plus 3, which is equal to a to the sixth. We have b squared times b cubed times b to the first, so that's going to be b to the 2 plus 3 plus 1, so that's b to the sixth. And then we're going to have, only 2 of our terms have c's, so that's going to be c to the 1 plus 2, because we have c times c squared, so that will give us c to the third. So 105, a to the sixth, b to the sixth, c cubed will be our product. All right, so now let's consider dividing 2 monomials. And so recall that the answer to a division problem we call a quotient. So the quotient of 2 exponential expressions with the same base can be simplified by writing each expression in expanded form or factored form. Okay, so let's look at the example on the right. We have x to the fifth divided by x squared. If we expand the numerator, we will have x times x times x times x times x. And if we expand the denominator, x squared, we will have x times x. Well, notice x divided by x is 1 and x divided by x is 1. So really what we're left with is 1 times 1 times x times x times x, which is just x cubed. So x to the fifth divided by x squared is equal to x cubed. Well, notice we would get the same result if we subtract our exponents. So x to the fifth divided by x squared is x cubed. And this takes us to our next exponent rule when we're dividing with like bases. To divide two monomials with the same bases, we're going to subtract the exponents of the like bases. So if we want to simplify y to the seventh divided by y cubed, to get our answer, we will have y to the 7 minus 3, which equals y to the fourth. In example P, we have r to the fifth divided by r. Once again, there's an implied 1 there. This will equal r to the 5 minus 1, which equals r to the fourth power. Q, we have 22k to the fifth divided by 11k to the fourth. So we're just going to divide 22 and 11. 22 divided by 11 is 2, so we have 2k to the 5 minus 4. So that's just 2k to the first power, so we're just going to write 2k. M to the ninth, n to the seventh divided by m to the fourth, n to the fifth. That will be m to the 9 minus 4 and n to the 7 minus 5. So that will give us m to the fifth, n squared. Alright, we have 8x to the ninth and 12x to the sixth. Now, since 12 won't evenly divide into 8, we are just going to simplify the fraction 8/12. So we're looking for the greatest common factor. The biggest number that will go into 8 and 12 is 4. So let's divide each of those by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. Okay? Now, I'm going to go ahead and just draw a division bar, because the 2 is going to remain on the numerator and the 3 is on the denominator. And when we do the subtraction with our for our like base as x, when we're simplifying that part, just understand that that subtraction is going on in the numerator. So we have x to the 9 minus 6. So we can write our answer as 2x to the third all over 3. I just want to point out, it would still be okay to write our answer as 2/3 with the x cubed right out front. But understand that x cubed is on the numerator. It's not on the denominator. We have negative 16a to the 7th b to the 9th divided by 24a to the 6th b. So the greatest common factor of 16 and 24 is 8, so let's divide each of those by 8 to simplify that fraction. 16 divided by 8 is 2. 24 divided by 8 is 3. So once again, let me draw my division bar. My answer is going to be negative. I'm just going to go ahead and keep my negative right out front, which is fine. My 2 is on my numerator. I have a 3 down here. On top, I'm doing a to the 7 minus 6 and b to the 9 minus 1. There's an implied 1 on the b as an exponent. So my final answer will be negative 2ab to the 8th over 3. All right, we've reached the U-try, so I'm just going to go ahead and turn off this recording right now. You all have a good day.